everyone, welcome to today's tutorial. So the plan for this tutorial is to teach Clarity smart contract language on the Stacks ecosystem. So we're going to be building like a project, and that would like give you understanding of where to use what, how to declare constants, how to declare data variables, map things together, map data together, and all of those things. So we're going to be walking through. I believe building a project is like gives you like the understanding that you need. So yeah, of course you can go through, but for this project the prerequisite is that you at least understand, you know what Clarity language is, you are familiar with the Stacks ecosystem, and you have seen the Clarity smart contract syntax, the Clarity smart contract language syntax before. So that is needed for you to understand. So in the course of this video, I'll be showing you how to like write the whole project, how to write like a smart contract. So but then if you don't know Clarity, you don't know you are not familiar with the Stacks ecosystem, I suggest that you go online, go search for Clarity Camp. Yeah, search for Clarity Camp. I've searched for it before. So yeah, when you enter, you just sign in. When you sign in, you see something like this. I've signed in already. So when you sign in, you see something like this. So you can read about the Bitcoin, you can read about mining and all, but then what we are focusing on right now is Clarity. And yeah, so yeah, I did not mention my name. My name is Bolan Hakonde. I'm a smart contracts developer, yeah. I'm also a front-end developer. I've been in the Web 2 space for about 3 years before I moved to the Web 3 space, and I joined the Web 3 space, which Stacks is my first ecosystem. I joined the Web 3 space last year. This year is 2025. I don't know when you'll be watching this video, but I joined the Stacks ecosystem space, or Web3 space, last year February. Then I joined the Stacks ecosystem last year, which is 2024 April. So yeah, since then I've been learning about Clarity language, learning about Stacks and all. So back to this. Yeah, when you get here, just go to Clarity Camp, and from there you click on continue. And from there you click on continue. So yeah, I'll employ you to go through from this module 1 all the way down to module 7, so for you to get the nitty-gritty and all. So one key thing that I would like everybody that wants to write Clarity smart contract to know is, because I believe most people are coming from different language. You're coming from Python, JavaScript, so the syntax, when you come to Clarity language, the syntax might be a bit different. I've heard a lot of people complain that the whole thing looks confusing, but just if I tell people that if you can just get these two things off your mind. I'm waiting for this to load. I will just show you. Okay, let's see this basics, Clarity basics. So let's see if this will come up. All right, so if you can just get these two things off your mind, the Clarity language is very simple and very straightforward. Like you can see here, it follows the lib syntax, and the lib syntax, they use the S expression. All these, like I said before, if there are two things that you need to get off your mind when you're adding, or when you're doing the summation operation, like you're adding or subtracting or multiplying or something like that, the operators always come first. Then whatever you are doing, there is no comma, so whatever you are doing, then the next thing you're doing. So if you're doing like 5 minus 4, you'll be having the minus operator first. Let me see, I'm not sure this is, let me zoom in. Alright, you'll be having the minus operator first, and then okay, I think we can edit it here. Be having the minus operator first before, okay, minus, yeah. So we have 2. So whatever you are doing, the operator first. So that's is 1. Then the other, you'll be seeing examples, you'll be seeing how we do those things. So, and then the other thing that you need to know or need to get off your mind is the brackets. So the brackets are not the issue, they're just following the S expression that the Lisp language follows. So it's just the mimic of how Lisp language follows. Everywhere you see us writing any syntax, we start with the bracket and we end with the bracket. We start everything, we start with the bracket, we end with the bracket. Just like this two expression in one expression. So this expression is multiplying this expression. You can see we start with the brackets with the operator, then the answer we get from here multiplies the answer we get from here. So just we always start with the bracket and end with the bracket wherever you see. And then the way we write comments is 2 semicolon before the comment, not double slash like in JavaScript and all. 2 semicolon before we start, before at the beginning of the comment line. So those 2 things, if you can get them off your mind, Clarity is very, very simple. I mean, you're just defining a function, you just literally say define public and all. So yeah, we're going to be working on an example or on a project, and I'm going to be showing you how it works. All right, so quickly, the project I plan to work on is an event ticketing project, and let me open a terminal. So yeah, alright, I believe this is clear enough. So yeah, we're going to be working on a project called a smart contract that is an event ticketing smart contract. So we're going to be integrating with the front end later on, but I just want to show us a walkthrough of how to write all of this, of how to write the Clarity smart contract from the start to the finish. So I hope you're able to learn 1 or 2 things. So yeah, let's begin. So to set up a project, you need to make sure, if you go through, just like I recommended, if you go through this, you should be able to install Clarinet. Okay, installing tools, you should be able to install Clarinet and all of and everything that you need to, everything you need to get started. You should have them by now. So then yeah, for you to set up a new project, all you need to do is Clarinet new event, let's say event ticketing. I hope I'm right with my spelling of ticketing. Well, you permit me. Ticketing here. Why? Yeah, allow hero to learn from their mistakes. Right, this should be coming up. Yeah, nice. So you see we have a folder there. Alright, we already have them scaffolded, so I'm going to quickly go to my VS Code so we can probably view all of this. Amazing. So yeah, let me zoom in. So for now we don't have anything because we have settings. Let me just walk you through. In the settings directory, we have the devnet.toml. This is for you. This is a setup for you to deploy locally on your system. You have a dummy wallet. This is dummy wallet 1, and this is the address for dummy wallet 1. Secret key but this is like the seed phrase for dummy wallet 1. Also you have dummy wallet 2, and so on and so forth. Okay, this is dummy wallet 1. This is what you will use to deploy, and it has been funded with this amount. So all of the wallets here, these are all dummy wallets, and all of the wallets here are just set up basically for your local deployment. So then you have the testnet. So when you want to deploy to testnet, you already have your RPC for testnet, and this is the fee, which is like 0.01 STX, because Stacks uses micro, that's like 3 zeros or so. So yeah, this is this place here is where you place in your seed phrase. So in case you want to deploy, you have to deploy with a particular account. So then you get your seed phrase from that account and you deploy here. So I won't be showing all of those. Maybe if there's a request for it in comment section, I'll do something like that. But I believe anybody that knows at least Stacks ecosystem or that is familiar with the blockchain space should know how to get their seed phrase. But regardless, I would find time to drop a resource to that. So yeah, and then for mainnet, same thing, just like testnet, you put in your seed phrase here. And so here we have test. Okay, I've not run any projects yet, but then I'm just showing you through. So this is the configuration file for our smart contracts. Your project name, description, author. Then here you have the main details for the contracts. So when I scaffold a new contract, you see this appear. This is commented out. And so yeah, another thing you need to know is Clarity language was built with Rust. Of course it follows the Lisp syntax, but it was built with Rust. So that's the reason why we're having the Rust config file here, the .toml. That's the reason why we're having the Rust config file here. So, and then for you to comment, this is not Clarity language at all. This is still Rust family language or something like that. So it follows, this is how they configure things in Rust. So, and then if it is comment, you have the hash. So all of these are commented out, but when we run a new project, we see that we have something there already. So yeah, basically those are the most important things you need to know. Okay, then this package.json is for us to run tests. When we have our test, you see an example test. Let me just run a test for you, or let me just like scaffold a project for you, so that I'll just go through everything once and for all. Alright, so to start a new to scaffold a new smart contract file, it is necessary you run the command, and I will show you the reason why it is necessary you run the command. So the command is Clarinet contract new, then the name of the smart contract file, which is say event ticket. Yeah, so we have this. So you can see that command did 3 things. It created a new file for us, created the tests for us, then added it to the config. So we see here that this has been added to the config. These are all the details. So that is why it is necessary for you to use the command. Of course, if you know what to do, you can come and fix it here directly yourself, but then it is always advisable to use the command, so you won't be having anything off point. So you have the name of the contract here, the path to the contract, the version of the contract, and the version of the contract. So yeah, that's the reason why you need to run the command to be able to set all of these things up. So that being said, okay, yeah, the tests. So you can see our test is written in TypeScript here, and we'll get back to testing, but for now our test is written in TypeScript. That's the reason for this package.json. We use v-tests to like tests, and when we're integrating with front end, or when we're testing, we'll see all of those in action. But for today, we're going straight to the Clarity smart contract language. And so you can see here some comments here. We have title, version, summary, description, then traits. What traits simply means is it deployed for in the smart contract sense anyway. What trait simply means that we want to follow a pattern of a contract, and that everybody agrees to, everybody uses, so that we don't have to like default in, so that if any front end have to call that kind of contracts, there is a pattern that front end would follow, not so that everybody don't have different ways they call from the blockchain. There's a pattern where everybody should call from the blockchain. So that's the reason why we have traits. And then in case we want to define tokens, constants, so I don't know, maybe I should remove all of this, or maybe I should leave them. I think because I might not follow, I think I will remove them. So yeah, let me remove them, but then you can follow them, because most of the time this is like the best way to the best pattern to like write your contract. Your constants first, you define all of your constants first, be it error constants and all, define everything first, then data variables, then you define your maps, or define your maps, then define your public function, you define read-only function, you define private functions, and if you have any like admin functions, I prefer to define my admin functions down. I don't know where others prefer to define their admin functions, but I prefer to define my admin functions down. Yeah, so that's basically it. So I'm going to be removing everything. We're going to be starting all over from beginning. I think I need to shut this off. Never. Yeah, let's see. I hope that saves. This doesn't save. So I'm going to like come back. I need to like properly set this off. I need to like come back. Alright, I hope that has been set, and that should not happen anymore. So yeah, let's continue. So give a description, and what should be in the description? Event ticketing smart contract written in Clarity. Language. Yeah, cool. So yeah, following that pattern, the first thing you should know, or the first thing that we need to do is define constants. So we're gonna, of course, we won't know all of the constants, but then should like have some basic knowledge of some constants that you would want to be doing, right? So let's just call that constants. Yeah, so that we'll follow a proper commenting and proper description and proper way to write the smart contract. So yeah, we're going to be defining errors first. But a proper way to write smart contracts, we'll be defining errors based on the proper way to like write smart contracts. So okay, the reasons for defining errors first are for debugging. So say in this contract, I've written this contract, so just to be sure, mistakes that are expected, but then I know we would still make mistakes because I'm not perfect. So yeah, it is always necessary first to define all your errors. I could say we should continue then get back to defining the errors, but it's not bad to like define the error. But yeah, first, you need to the first constant that I know we need to get is who is the person interacting with this contract. So yeah, that's the first constant. So like I said before, whatever we are doing in Clarity Smart Contract language, we use the brackets. We start with the bracket and end with the bracket. So if you're going to be defining a constant, if you're going to be setting up a constant, unlike in JavaScript that you have consts, I guess, yeah. In Clarity Smart Contract language, you just speak the English, define constants, give it the name. So whoever is going to be interacting with this contract is like the whoever deploy this contract is like the contract owner. So right, and the expression, which, or like the defined variable, or yeah, like the defined variable. So this is the name of the variable owner. This is the variable that will be called, or the constant name, sorry, not variable, because there's another syntax to define variable. This is like the constant name. And so then the TX sender is recognized as returns the original sender of the current transaction. So whoever is interacting with this thing whoever is interacting with this smart contract is called the TX sender. It's always called the TX sender, and it has a data type called the principal data type. But then we'll get to all of those, and if you had gone through the basics, you would know all of these things. So yeah, and we want to make sure that whoever is not interacting, this is when we now start defining the errors. So whoever is not interacting with the with this contract, we should get an error. We should get an error out of the person. So let's say the error name should be error not owner, or error this requires that you should be an owner. So yeah, error this requires that you should be an owner. Yeah. So and then the error code, we give an expression of the error code here. So let's start with 100. So the way we define errors is by using error u100. Yeah, error u100. So yeah, so anytime it is not the owner interacting with this contract, we get the error, or instead of getting out the code, we might get the code, and then we know that we'll get this error, and we know that this is like the error code, and we know that okay, this is like not the owner, like whoever is interacting with this project is like not the TX sender. And also there's a way we're going to do this that would give us, there's a way we're going to check this, validate this, so using this error. So the next error that I believe we should define first is an error not found. So say there might be different case that we would be needing the error not found code. So but for now, when we get there, we'll get in touch, or we'll get to know the reason why. But for now, there might be cases where some things are not properly checked, and so we want to like return an error that this is not like found. Maybe you're trying to like withdraw something, and you're not authorized to withdraw, or there's no even like, maybe you're trying to like withdraw a particular amount from your balance, and there's no really any amount in that balance. So we should at least get an error of not found, or something like that. So yeah, an error not found with an expression of this error. Let's continue from our 100. So let's say u101. Yeah, so you can see we started with the bracket for another expression. Reason why we not have reason why we are not having a bracket for this is just one. This is like a variable name. So but then this is like a whole expression. So for, let's say, for every expression there is need to start with a bracket, or for every syntax there is need to start with a bracket and end with a bracket. So yeah, and then we want to also check for say if you already log in, let's say for example, well, there are other cases we might use it, but if you already logged in or you already signed a transaction, you should be able to get an error that instead of having to try and log in again, you should be able to get an error that you already logged in. So until you log out before we get you. So that kind of error, it might not be in the case of being logging in with your wallet. It might be in other cases, but I just use that as an example. So we define another constant error with the error code, say it already exists, or yeah, let's use already exists. Yeah, with an expression or with an error code of U102. Yeah, perfect. All right, so for this contract, okay, maybe we should just let's start defining the data variable straight up. Let's define the data variable. So okay, yeah, I will call this the error constant. So let's say this is like indexed, the error constant. All right, so let's define data variables. We'll definitely be needing them. So data variables, like in other languages, are the ones you use var, like in JavaScript, are the ones you use var and let, I guess. So these variables can be edited. They are mutable, but constant variables are not mutable at all. All right, so yeah, what kind of data variable are we like expecting? So it's an event ticketing contract, and I believe we want to, for each ticket, we want to count the tickets. So we can have something like tickets, like event ID or like ticket ID. So for every ticket that everybody books, there should be like a count. So say there is an available number of okay, there are different events, and each event has different number of tickets. So we have, like on our platform, we have like 5 people had already created an event, and then in each event there's an available number of tickets, and so we want to be able to count when people get book or sign a ticket. So I want to be able to like count that, okay, if probably we have 1,000 number of tickets, once it gets to like 1,000 number of tickets, we should probably have an error not found, or an error no more tickets, or something like that. And if you have booked the ticket, you should be able to have like an error already exists, like an error already booked the ticket, or something like that. So yeah, quickly let's define. So also, why if you're going to be defining like a data variable, we still use the same English, define data variable. With then I could say event ID, but let's follow the way blockchain will properly do this. I think the way blockchain counts IDs with what's called nouns. I think it's spelled NON, or is it U? I think it's NC. Yeah, nouns. Yeah, this looks like it. So then the data type, which you would have covered while you go through the Clarity Count basics, is uint, because I mean we'll want to count it. So uint, and then for now the value is going to be set to 0, u0. Alright, and also this is for events. Also for the tickets in an event, we also want to have that set up to tickets. Yeah, we also want to have that set up to u0. Yeah, we also set that to u0. For now we'll be coming back to this, but yeah, for now this is like the major things we need. Yeah, any other thing we would know, we'll go back to it, but like this, like major things. So also another thing we need to define is maps, data maps. Yeah, so we need to define our data maps. And what would we need? Okay, yeah, we will be needing, based on events, what kind of data are we expecting if you were to create an event or something like that. What kind of data are we expecting? So that is what we'll be defining here. So, and then yeah, we'll be mapping it to an event. So yeah, define, where's the map? Okay, define map, the map name, events, and yeah, maps use a key value pair. So a key can come with a data type. Let me call it a data type. A key can come with a data type and then can have its name there, and you can just declare the data type straight up. If but then you can give it like a variable, a key name, and then a data type. But then for now, we're just going to be giving it a data type of uhints, and also you can have a value name. And yeah, for value name, we can keep it, because I mean we would want to like know the names of the data we're expecting. So for like value names, we can leave it, but for like key names, we can define just like it was. Let me see. Yeah, you can define, say it's going to be ticket events or something, tickets events, and then you have the key type to be uhints. But then I prefer to like write it like this. Keeps things simple for me. There are other reasons why to write that like that, but let's keep it like this to be able to. So let's keep it simple like this. And we'll define so an event needs to like have like a company or organization name, or who's the organization. So the organization definitely would have like an address, and like a name. And let's just start something. So name, first name, organizer, this should come with, say, with an address. So like I said, the data type for an address is principal, just like the data type for like numbers is like unit, on-site integer. So principal, and then we expect a name. Which we know that would be a string of say, yeah, let's use ASCII. Let's define a string of 100. At least, I mean, the name should, let's just to keep everything not too much information getting. So also venue of the events should let's keep it simple too. Should is a string too, and it should come with ASCII of 100 too. All right, and the total tickets, as I mean, somebody has already created an event, so the total tickets, that would be in numbers. So yeah, we use an unsigned integer. We should have an event date. Let me put it here. Let me put it up. An event date. Yeah. So while you are setting up your events, you should give a date, and that will be calculated with the stacks block height. So we should have that in uhints. I mean, because it's going to be numbers, so we'll use the block height. I think 144 block height is I'll get back to you on this, but I know that 144 block height is like 1 day, so 24 hours 24 hours block height is 144 block number or block. So this is not really, but then I'll get back to you on this. Yeah, I think I'm right with this. So yeah, also we want to be able to know if a ticket is still available. If not, we should be able to, or want to know, yeah, we want to know how many tickets have been sold. Yeah, I think we need to know how many tickets has been sold. So we total or tickets sold should be also a unit, and is an event still active or it's not active? So that would be like a boolean. So yeah, we need to check that too, or we need to get that kind of data. So while you're creating an event, you should be able to know when it ends and when it starts, and yeah, it's still active. So if it's ending, we're just going to like do a function that is going to like, once this certain number of dates reach, there should be like an end. Like this should be false immediately. This should be set to false. But yeah, okay, let me see, what else do we need? Any other thing we need, we can come back to set it up. So let's keep going first. Okay, we have error here. That's because we did not put comma here. All right, so let's continue. So yeah, we're going to be let's I think the next thing that we need to like get is like I mean the tickets data. So let's define another map. With the name tickets, and also yeah, this, okay, I think I would be explaining something. I think there will be a time that we'll need to like map ticket ID and the ticket type with the ticket price info or something like that. So we're still going to touch like explaining this. So but for now, let's like define like map the expected data to like a particular ticket number or a unit. So like yeah, mapping a ticket number or ticket ID to which is the unit to the ticket details. So for now we can still call this ticket ID and like give it a unit, but then let's call it units. Okay, let me make mistake here. Alright, so what the details we'll be getting from a ticket should be, I mean for a ticket there should be the event ID, right? We should be getting the event ID. Yeah, I think that would be smart enough. The event ID that would have all of these details. So yeah, okay, and Another thing we should be getting is who owns these tickets. Yeah, who owns these tickets, and that will be like with the address, with the data type of the principal. And another thing we're checking is the ticket type. Yeah, there will be need for us to know the ticket type. Maybe it is VVIP or something like that. So that should come with string ASCII. It should like 20 is enough. Oh, yeah. And then yeah, we should know the purchase price. Purchase price of that will come with the data type of units, right? And is okay. Another thing we can check off is okay, yeah, has this ticket been used or not? So this will be coming with a boolean. So as that would be too long. Is used, yeah, is used should come with the boolean. And if it's listed for resale, should we add this? Yeah, let's add this. If we don't need it, we'll remove it. I think we'll need it. Okay, yeah, so basically this, like, oh, we've done a lot, we've just covered this. Yeah, so basically I think this this like the major things we need to define before we like start writing anything. So for this version, we're just going to be like creating all the functions down. So we're just like following a pattern. So we'll go through the public function, go through the private function, and all. So yeah, so let's define the public function. Public function. So yeah, for a public function, what are the public functions that we'll be needing for an event ticket smart contract? Yeah, of course, we will need somebody to like create event. Yeah, create events, right? We'll need to set the event price. We need to like set the ticket price. Set the ticket price. And we should be able to also cancel an event, but then we just like we cancel. The event will still be present because nothing can be deleted from the blockchain. So cancel an event. What else? Okay, this would be the admin's work. To do all of this would be the admin's work. And for a user should be able to purchase a ticket. Yeah, that's user should be able to purchase a ticket, or purchase a ticket for an event. And also the user can resell this ticket. So the user can list this ticket for resale. Another thing is that another user should be able to buy a resaled ticket. A ticket that has been listed by a listed ticket for resale. Yeah. And major thing is that and users should be able to use the ticket to like sign in or something like that. So yeah, what else do we like need? Okay, another thing is if a user like does not maybe just book the ticket wrongly or something, or booked multiple tickets, it should be able to like after canceling, we should be able to like get a refund or something like that. So yeah, I'll request a refund. But can this be possible? Okay, let's see how it goes. Request refund. I mean, it's your money, but then yeah, it's your money. We should be able to do something like that. So yeah, that's like what we need to do. So quickly, we're just going to be defining those. So this should be unique. Let me make this unique. It should be unique. I think, am I getting the uniqueness properly? Yeah. Don't mind me. So yeah, this should be actually be different. So let's start defining those functions. We're just going to define an empty function, and then we'll get back to them. So yeah, to define a function that can be accessible out like a contract, a front end can call it, another contract can call it, to be called a public function. But to define a function that can only be used within the contract, those functions are called the private functions. So yeah, we define a public function by simply defining a public function. I like that. Define a public function by simply defining a public function, then give it a function. You can see Clarity is just so straightforward, very secured and very straightforward. It's like you're speaking English or like you're writing English. So no offense, but I mean, I don't know if Clarity was made in other languages, but if it was made in other languages, it's more like you're speaking your language while writing. But then I don't know if it's written. I think it's still written in English. So you're just that's why it's called Clarity. I mean, so jokes apart, what are the things that we need to get from the parameters that we need to get? So if we're going to create an event, you need to create an event with at least a name. So also I said for every expression you need like a opening and closing brackets. So given a parameter with a data type is like an expression to me. So so a name with a data type of string, ASCII, strings ASCII, yeah, and your name should be 100, right? Your name cannot pass more than 100, right? So yeah, another thing is while creating an event, we need to know the venue of your events. So that should be coming with string of 100. Okay, see me, I forgot to, yeah. All right, another thing is that definitely an event date with a data type of uint, right? And also a ticket, the total number of tickets you are releasing, right? Yeah, total ticket. Of a uint, yeah, uint. So I think that will be all. That should be all. So for now this would be empty, so we're just going to like return okay. So yeah, we're just going to like return true. Okay, so let's properly format this. Or we could leave it like this, but I like my contract to be neat. Okay. Yeah. So all of our logics would come here. Or logics and expression or implementations. Okay, this is, yeah, so we'll come back to that. So another thing, let's see, we've not saved for long. Okay, no errors so far. Yeah, another thing, let's define a function to set the ticket price. So yeah, to the set ticket price function, what we expect this to do is just to set ticket pricing for different tier, maybe VVIP, IP, just a regular person. We want to be able to set all of we want to be able to set like the price. So yeah, so this would like cover what we expect. Okay, let's just define the public function. Let's give it the name set ticket price. Something is coming to me now. When we're setting a ticket price, we'll be needing something very important, and that is like a platform fee. So our platform fee would like be calculated with the ticket price. So I think we need to like define a public define a constant here. Yeah, define a constant, and to be called the platform fee. That's very important, because I don't know about you, but me, I want to make money and I have to make my money. I mean, if I'm building a very good platform like this, I should be able to like get some tokens. So this is like very small. This is like 0.2 STX per creating a platform fee. So this is not gas fee. Let's be guided. So yeah, I think yeah, that's what I'll be needing. And the variables to be able to like do this, to be able to like set a ticket price, first would be the event ID. Yeah, you need to like get the event ID. Also the ticket price, the ticket type. I mean, the ticket type. Why do I keep making this mistake? I think that's going to be common for everybody. Ticket type should be a string. ASCII 100 is too much. 20 is alright. Yeah, 20 is alright. So yeah, the ticket type should be 20. And price, very very important. Price should be unit. And what else? Whatever it is that is left would be coming. Okay, yeah, the quantity. That's very important also, because when it finishes, I want to like be able to, or not even when it finishes, like want to like be able to know how many you want to like purchase, maybe for you and your like your spouse, or your like your family members. So yeah, want to have that. So I think that should be So then we'll be implementing this later. Whatever is supposed to be in the body, we'll be implementing it later. So let's see. Okay, what do we? Okay, logics and implementation. Let's use that. Logics and implementation. So let's just set this to okay, true, so that we will not have, because if we don't set anything, we have error. Let's save this. Boom, we have error. So like we want to be able to like return true, return an okay. I mean, so yeah, we've escaped the error. All right, so the next thing that we'll implement is like, we're just going to like write the empty ones down. So this I mean, you should be able to have the ability to cancel an event. So I don't think this should take much, this cancel event. I don't think this should take much. We can just cancel an event with the event ID. That is like pretty straightforward. Cancel an event with the event ID. Right. I mean, you don't need any other thing now. Okay, so just let's give it that name to logic and blah blah. Okay, and we set it to true. Okay, true. We return okay. So we return okay, true. Yeah. All right. So yeah, this let's differentiate this. This should be for the users. The above is for the admin. It should be users function. So let's give it the admin functions. All right. Yeah. So now to the users functions. A user should be able to purchase tickets. So let's define an empty function to purchase tickets. Okay, with the function name purchase tickets, literally purchase tickets. And the data we should expect, or parameters we should expect to get, being through the event ID. You should be able to purchase a ticket through the event ID. Right. Should be able to purchase tickets through get a ticket type to be able to purchase a ticket. That will be a string ASCII of 20, because that's what I've been using. And I think to purchase tickets, you just need an ID and a ticket type. Do you need, yeah, ticket ID and the ticket type? All right, we did not define the map for a ticket type, an event ID and a ticket type. And I was thinking of it, like I was thinking like ticket ID. I just remembered we did not define that. We did not define that. Yeah, we did not define that. So let's define that. Let's define it here. So let's define the map. So yeah, I was saying we're going to like explain this, the need for this. So yeah, so for a ticket price, for ticket pricing, we'll need to map a ticket pricing with this kind of data. So first we need event ID. We need an event ID. Should be units, of course. Right? Yeah. And okay, yeah, and a ticket type. Yeah. ticket type should come with a string, else we're going to like, and then we define it with 20. Yeah, so yeah, and then we were mapping it with the price. We're mapping it with the price, having a unit. If it's available, want to be sure with the price and its availability. Based on number of availability, and a number of sold. So yeah, let's format this properly. Alright, so I think this is pretty straightforward. Ticket prices, was to be able to map the event ID or the ticket type with the price and a number of available tickets with number of sold tickets. Yeah, I think this pretty much it. Okay, so then we get the body. Okay, what is this? So we use, let me see, yeah, and then we return an OK true. Okay, there's no error so far. Yeah, I think this is going on well. I'm trying to think if there's any other thing that I must be missing out. So far doubts, so let's if there is, we'll come back to them. So yeah, let's give users the opportunity to be able to list their tickets. So we define another public function. Let me try something. Can this work? Yeah, this works. D-P. Okay, yeah, this works. So list tickets. Let's keep it a bit straightforward. List tickets for resale. List tickets for resale. Yeah. What else? Okay, well, the parameters that we'll be needing is at least if you're going to list tickets, you get to list a ticket with the ticket ID, which is going to be unit, and the resale price, because I mean you would not want to resell it with the original price. So yeah, we're going to be the resale price, with the unit. So yeah, that should be all. Let's format this properly. Okay, so we want to logics and implementation here, and return OK true. We'll be coming to all of this. No error so far. Alright, then the user should be able to buy resale tickets. So let's quickly run through this. Yeah, simply buy resale, by resale tickets. Alright. We expect the ticket ID to use to buy resale tickets. So we get the ticket ID that comes with a unit. So we need to wrap this in the bracket properly. Alright. I think for the body we use so let's just logics and then return okay true. Okay true. No error so far. And also should be able to use a ticket. So for you to be able to use a ticket, you use a ticket with the ticket ID. Tickets. Use tickets. Use tickets. Expecting the ticket ID. Expect the ticket ID. Just a unit. Alright. Okay. So the logic and implementations will be done here, and then we return an okay true. So in Clarity, the last thing that we'll be needing is for users. This I still think, but let's just put it for users to be able to request refund. Something tells me we might be using this. So request refund with going to be getting the ticket ID. Going to be getting the ticket ID. What does this seem like? I forgot the spelling of ticket ID. Alright. Yeah. Okay. And then logics and implementations. And okay true. Yeah, so pretty, I believe this is all that we expect to have. What's left remaining is the following pattern. So we need to like have our read-only functions and our private functions. So those are the things that I think remains. And let's see, read functions. Now read functions, read-only functions, or read functions are functions that you get from the blockchain. You get like data that you want to get from the blockchain, you get them from the blockchain. So most times these are the data that will like be displayed to the front end. So let's list out all the things that we need to expect. Of course, we need to like get events. After events have been created, we need to like get those events and display to the front end. We need to like get the ticket details. Get the ticket details. That's the details. Yeah. We need to also get the price. Get the price. Get ticket price. Alright. We need to also, I think this is all we need to get. Yeah, the events, the ticket details, and the ticket price. So quickly, let's write a function to do those. So to write the function to do those, we just define a read-only function, and then yeah, give it the name get events. Get events by an event ID. basically. Get event by event ID. Logic and implementation will be done here, and return okay true. Okay. Also, to be able to, we need to be able to read the blockchain and get ticket details. We need to like get ticket details, get tickets. Let's remove this. Get tickets. Yeah, this is okay with. So get a ticket by the ticket ID. Get a ticket by the ticket ID. Yeah. Alright. Return okay true. So let's just put the logic here. Okay, and lastly, for the read function, we should be able to get the ticket price and be able to display it. So define define get ticket, define get ticket price. And we're getting ticket price with and then we're getting ticket price with the mapped, or we're getting ticket price with with the ID, ticket ID and ticket type. Yeah. So yeah, event ID with new hints, and okay, this is yeah, tickets, ticket type. Yeah. So ticket type, so get the ticket type with RNG ASCII with 20. Yeah, get 20. Something seems wrong. I'm not sure what, because I expect this should give a color. But let's see. Maybe nothing is wrong. I think nothing is wrong. Everything is cool, but I expect that, I think maybe my spelling, but I expect that I should get this kind of color, and I can see, oh, I'm putting in a colon. This is not like needed. Yeah, so okay, true. Yeah, so that's basically it. So quickly, let's see what kind of private function would we be needing because we don't want anybody to be able to call in we want to like be able to create a logic that's calculates our fee. Yeah, that's like a good example for a private function. We want to be able to calculate a function. We want to be able to create a function that calculates our fee. So we need to like make that private. Like, don't tell anybody. This is how we calculate. I mean, it's going to be transparent at the end, but then we need to like be able to declare this, not so that no other person can be able to like call our fee, and then this private function. So what do we have? What do we want to do in our private function? We need to like calculate fee. Alright, and we need to like transfer our own fee to us, right? We like transfer our own fee to us. So okay, transfer fee. So yeah, we need to do those things. So let's write the function for that. So define private, and then first function will be calculate. First function will be calculate fee, and we want to get the amounts. Yeah, let's get the amounts in units. Yeah, and then we give an amount here. We'll basically just be returning an amount. So yeah, that is what I think that's the logic that we need for that. Whatever we still need, we'll be defining that later on. So another function, private function we need to like define is like transferring that fee. So we'll basically just be calling this function inside this function, but for now we're just creating an empty transfer function. Transfer with fee, okay, and also we expect the amounts in units. Alright, this logic will be for now. Alright, so okay, this, not this, I think this should be, yeah, this should be returned true. So yeah, we did not really see any error in this place, so that's because we've not started like implementing things. So if I save, there is like no error, but like we've come to like the end of like the first stage of this contract. So I'm going to be recording another video in continuation of this. So we're going to start implementing these logics. So for now, we'll just show you simple way to at least if you're going to write a smart contract, you should like have an idea of what you should expect to see and all. So if there is, I'm going to like think over all of this. If there's anything we need to add, we'll be adding it in our next video, but for now I think this is like pretty straightforward. Yeah, this should be pretty straightforward. So thank you for watching. See you in my next video.